Hey guys, this is Derek Duplessis, host of Purpose Rockstar. It's a podcast where we interview people who found purpose in their career in all kinds of fields.
Welcome to the Purpose Rockstar Podcast, inspiring stories of people who found purpose in their careers 5 days a week. Unleash your inner rock star and tap into your highest purpose with your host, Derek Duplessis.
Welcome to the Purpose Rockstar Podcast. I'm your host, Derek Duplessis, Executive Director of the Duplessis Foundation. We're helping inner city entrepreneurs to pursue their purpose by training them to run a successful business. This show is an extension of our mission to help you and people all over the world find purpose in their work. Let me tell you a little bit about today's guest.
Today's interview is with Sara Seager. Not only is she a good friend, but she's also one of the most well-known astrophysicists in the world. You'll see her all over the place, in Ancient Aliens or on the Star Trek DVD. She's everywhere. But in this interview, you actually get to understand the person behind all of the science. And I think you really will enjoy this.
Now, one other place that I wanted to go with you was, we've worked together, so, it's nice for the Purpose Rockstars to know that. And you have a fantastic team of folks that work with you and folks that you've mentored. Just single out one and talk about the work that they're doing.
Okay, it's hard to play favorites here, but let me think.
No favorites, just somebody that comes to mind as doing interesting work.
Okay, I will talk about my student, Julian DeWitt. Julian is from, and he came here initially on an internship, went back to Belgium to complete his master's, then came here to do his PhD. What I like so much about Julian is he'll come here and have wonderful ideas of his own, and he has this tools and skill set to actually work those ideas out on his own. So an idea that we came up with is how to measure a planet mass in a very new way. It turns out that planet mass is a very fundamental factor. Our Earth, we call it one Earth mass, but Jupiter is 300 times more massive than the Earth. So it's a pretty basic thing here, but for a whole class of planets, all we can do is measure their size, not their mass. And he came up with a way, we came up with the way that he worked out all the details to measure the mass of a planet in a new way. And that's really exciting.
Very cool. Now, let's transition into what's exciting you right now. What's on the horizon for you, Sara?
What my main project right now, what I'm most excited about, is a space mission concept to find another Earth. And there are many ways we can imagine to find another Earth, but the one that I'm leading a team that's studying it, but the concept for which I'm leading a team who is studying it, we think is the shortest path to finding another true Earth, if they're common and if they exist around our nearby stars. And what this is, we call it the Starshade. It's a Starshade and telescope system that would be launched into space. And the Starshade is typically tens of meters in diameter. That's big. And it would have to be separated from the telescope by tens of thousands of kilometers. What we're imagining here, it's like, you can look at the sun or look at a light in your room, and you stick your hand out in front of your face and block out the starlight. With the concept, but your eye would be the telescope and your hand would be the starshade. The thing is that shade has to be a very specific shape. If it was going to be a circle or a square, we'd have a problem with diffracted light. Now, light from a point of like a star point source, if you image it, if you were to block it with a big screen, you would think it would all be blocked out. But no, because some of the starlight actually comes around the edges of that screen. And the analogy we have is like dropping a pebble in a pond. If you drop a pebble in a pond, you will see ripples. If you try to image a star that's a point source, you will see ripples. Those ripples, actually, you know what? They're way brighter than the planet you're looking for. Actually, you know what, Derek? I forgot to say a kind of critical thing here. Okay, let me back up. We use the star shape to block out the starlight because the star Because for an Earth-Sun analog, the star is 10 billion times brighter than the planet. Just think about that for a second. To try to comprehend how vast that number is, I always like to think about money. What can you buy for $1? I mean, not a whole lot in Boston, actually. But what would 10 billion buy you? I mean, wow, 10 billion. It's so big we can't even imagine what we'd spend it on. So that's the thing. The star is so bright compared to the planet, we have to have a very special way to block out the light. So we can't have a circle or a square screen. It has to be very specially shaped. And people have worked out a very special shape. It looks kind of like a flower. It looks kind of like a flower with petals that are very, very specially shaped and have to be manufactured to very precise levels. So the star shade is what I'm most excited about, and it's what I'm spending most of my time on right now.
I love it. It kind of reminds me of the concept of change blindness. And that, I don't know if you've ever heard of change blindness, but it's the idea that if you show someone two images in quick succession, it's really hard for them to tell them apart, if the images are even slightly close to one another. But if you slow it down, if you have some type of mechanism to slow down somebody processing, seeing that image, then they can see the differences a lot easier. So the star shade is like that thing that helps people see these atmospheres much better. So it's very interesting.
There's more to that interview. Yeah, more. And you can find all of it at purposerockstar.com. Link is right there. Yeah, right there. Yeah, right there. So it's really, really awesome that you can go to purposerockstar.com. If you're one of those on-the-go Apple people, you can check it out on iTunes. There's the link. And for my non-Apple people, I'm going to make sure there's a link on Stitcher somewhere next to me. So you got iTunes, Stitcher, and purposerockstar.com. Tell your friends, tell your family. We're on Twitter and Facebook, and somehow we'll be on LinkedIn. I don't know. But at least we'll be on Twitter and Facebook. And one final favor. Pursue your purpose. It needs you.
To know that there are planets like Earth around other stars. And we also believe that someday, hundreds or 1,000 years from now, people will find a way to travel to those Earth-like worlds around other stars, and they will see us collectively as those that first made the discoveries.